Let us now continue with what we are doing. So what we said was that given a system of equation, it leads to the notion of vectors. Fine. So let's go into vectors and matrices and things like that. All right. So definition. So what is a matrix? So a matrix is just an array of numbers. Matrix is a rectangular array. All right. Of what? That will depend on whether sometimes it could be real numbers, it could be matrices itself, it could be functions. So the entries could be anything. A matrix is just a rectangular array. All right, that's all, nothing else. Whatever the entries that we'll think of depending on our choice, problems, and things like that. Fine. So we generally write a matrix A as, for example, 2, 4, 6, 1, minus 2, 3, 2, 1, 4, 7, 2, 6. Suppose I write like this. Fine. Then we say that this matrix has 3 rows and 4 columns. So these are the rows that you are looking at. The horizontal parts are rows, horizontal arrays are rows. Fine. Vertical arrays are called columns. Fine. So this important thing that we need to understand is how do we represent them. So when I write A of 1 and this, so this part indicates row. The first part is row. The second part corresponds to column here. So here I'm not saying any column here. So it means that I'm taking all the columns. So I'm looking at the first row here. The first row is nothing but 2, 4, 6, 6. If I want to look at the second column or the third column, third row, suppose, third row will be nothing but 2, 1, 4, 7. This is the third one. So these are the rows that I'm looking at. This part corresponds to the row. The first part corresponds to the row. If I want to look at the columns, suppose I want to look at the third column. So this is the third column that I'm looking at, the second part. Here there are all the rows are there, all rows. And here I'm looking at third column. So it is nothing but 6, 3, 4. Is that okay? Fine. If I want to look at just some entry, say, suppose I want to look at 8, 2, 2, second row and second column, this entry is minus 2. Fine. Sometimes we may write it as A 2, 2. Sometimes I may write it as A of 2, 2. So depending on different times and problems, the issue that I may have, or my mood and things like that, I may write it differently. Fine. But this is very important, that what I'm talking about here, rows here and columns here. So what I'm saying is that if I write here A of I and this, it means I'm looking at the ith row. If I'm looking at this and J here, then I'm looking at the jth column. Fine. And in this matrix, there were 3 rows and 4 columns. So the size of this matrix A, size of, or the order of this matrix, order of A is 3 cross 4, 3 times 4. Is that okay? Fine. So this is an important thing that you need to understand. Then a vector, a matrix having exactly one row. All right. So matrix A basically looks like this: 1, 4, 7, 8, say 5. All right. One row. Then this is called a row vector. Such matrices. So such matrices should be written, not thus. Such matrices are called row vectors. So there is only one row. Then similarly, you have what is called the column vector. So what is a column vector? A matrix which has exactly one column. So something like this, as I said earlier, x1, x2 till xn I wrote that all our vectors should be column vectors. That was in the first lecture, we said that. Fine. So for example, 1, 4 is a column vector. minus 1 to 7 is another column vector of different size. We are not saying what is the size, but these are all column vectors. All right. Fine. So this is what you have to be careful about. What are column vectors? They are always column, means there is only one column. There are many rows. The size of the rows, we do not know how many they are. Then we have this notion of what is called a 1 cross 1. So if a matrix a matrix of size 1 cross 1 is called a scalar, and we remove the brackets. When writing them. So for example, if I'm writing this, A is this basically corresponds to the number 5 itself and nothing else, right? That's very important. Another thing I would like you to understand that sometimes my brackets are these brackets, what are called middle brackets, or some other bracket. I don't know what the bracket is, but anyway, these brackets. Sometimes my brackets could be this. All right. So for example, here I may write as 2, 4, 6, 6 like this also. This vector I could have written like in place of like 6, 3, 4. This is also allowed. Similarly for matrix also, in place of writing like this, I can write like this, which is 1, 2, 3, 4, 7, 5. I can write like this. Fine. So which bracket I am using, it should be clear that they are matrices or not by just looking at the instance where I am looking at those things. Fine. In general, what we have is we have matrix A. If I'm saying it is a matrix of size m cross n, then it is going to look like A11, A12. There are n columns here, A13 till A1n. In the second row, A21, A22, A23, A2n. And there are m rows here, so AM1, AM2, so on till AMN. That's the way we write it. Sometimes m cross n will be written here, sometimes it will be written here. Sometimes all this information that I have got here in the middle may be put like this. Fine. So depending on choices, you have to be careful and understand them. Is that okay? So try that out yourself. And you have already seen it in class 11th or 12th. So be careful, that's all. So definition. Two matrices A and B are said to be equal if one part they have the same size or order, they should have the same order, and two, the corresponding entries must be equal. Corresponding entries must be. This is very important for us. All right, that we are defining things axiomatically in some sense, that we are saying that this is a matrix and things like that. So we need to have what they are. So for example, if I want to look at this matrix and this matrix, even though they have the same entries, they are not equal. Fine. That's very important because their sizes are different. Fine. So you have to be careful about that part. Similarly, I have another matrix 0, 1, 0, 0. They are the same size, but they are also not. So these are not equal, as the entry in the first row, second column different. Fine. So this is what you have to be careful about, that when they are equal, when they are not equal, and things like that. Fine. Let's take some examples of some special matrices now. So example. So the first example is that of a zero matrix. Zero matrix. So generally I write just 0, but since we are looking at the initial part, so if I write 0, 1 cross 1, it's just 0 here. Fine. If I write 0 as 2 cross 1, so there are supposed to be 2 rows here. So since there are 2 rows, it will be 0 and 0, and there's only one column. If I'm writing 0 of say 2 cross 3, it means that 2 rows and 3 columns. So 3 columns like this and so on. Fine. So you have to be careful to understand it, nothing else. I'll do a lot of mistakes, so be careful. Fine. Then there's notion of what is called a square matrix. The square matrix. So a matrix A and M cross N matrix A is said to be a square matrix if M is equal to N. So number of rows is equal to number of columns. Fine. Is it okay? So if you look at this above example, this is the only one which is a square matrix. Others are not a square matrix here. Fine. But here I have got two square matrix here. This is a square matrix. This is also a square matrix. Fine. So you have to be careful. Then there's a notion of what is called the identity matrix. So identity matrix is supposed to be a square matrix or a square matrix with one on the diagonal. I've not yet said what is the diagonal, that I'll have to say diagonal, and 0 everywhere else. So if you're writing, so this will be always written as some I of n for n cross n matrix. So I of 1 will be just 1 cross 1, or which will be same as just 1 here. The way we write, as I said, a scalar matrix. A scalar matrix can be just written as 1 itself, just a scalar. I2 will be 1, 0, 0, 1. Right? I3, if I want to look at, it will be 1, 0, 0, 0, 1, 0, 0, 0, 1. So the diagonal is nothing but the diagonal of a matrix, the diagonal, or sometimes we use the word main diagonal. All right, is nothing but the entry corresponding to A11, A22 till ANN. All right. So they form the diagonal. All these entries, they form the diagonal together. Is that okay? Then there's a notion of what is called an upper triangular or lower triangular matrix. So upper triangular matrix. So there are two types of matrices, upper triangular and lower triangular. So if you look at the definition, that is a bit complicated. Matlab, you may get nervous because the way it is put, it becomes the other way around. Fine. So what I will do is that I'll just give you an example to say what is upper triangular, what is lower triangular. Fine. So upper triangular basically means that suppose I want to look at a 3 cross this. So these are square matrices. So upper means upper part may be non-zero, but the lower part has to be 0. Fine. So I do not know what these entries are, but I know that these entries are 0. Fine. So these entries could be anything. Fine. So for example, I can have here 0, 1, 4, 0, 2, minus 1, 0, 0, 0. I can have this. So this is an upper triangular matrix because the lower part here is 0 here. Is that okay? That's an upper triangular. Similarly, if I want to look at the lower triangular matrix, what I need that the upper part should be 0. So therefore, I can have here is 1, minus 2, 3, 2 here, 4 here, 5 here, 0 here, 0 here, 0 here. So this is a lower triangular matrix. Is that okay? So you can see that 0 matrix, when it is a square matrix, is lower triangular as well as upper triangular. Similarly, identity matrix is lower triangular as well as an upper triangular matrix, and things like that. Is that okay? So you have to be careful about that. Then there is a notion of what is called a standard unit vector. So then we have notion of what are called the standard unit vectors. So as I said, we are getting vectors as column vectors. So I look at from that point of view. So let me write what is the standard. So if I write E1, E2, so there are n of them, En, so it's no vectors of Rn if I want to write. Then I've got n of them. I would like to understand them. Fine. So let me look at R2 first. R2 corresponds to the identity matrix of R2 is 1, 0, 0, 1. So here E1 in case of R2 will look like 1, 0 and E2 will look like 0, 1. Fine. So I'm looking at the first column of the identity matrix, second column of the identity matrix. Fine. If I am in R3, then the vector that I have, the identity matrix that I have is of the type 1, 0, 0, 0, 1, 0, 0, 0, 1. So therefore the standard unit vectors in R3 of R3 will be E1, again E1 itself, 1, 0, 0, E2 which is 0, 1, 0, and E3 which is 0, 0, 1. All right. So they corresponds to the basically I, J, and K, things like that. Is that okay? So I'm not saying where it is. Once I write E1, E2 from the place that I'm discussing about, you can understand them. Is that okay? So nothing special, just spend some time thinking about it and you will get those things. Is that okay? Fine. Now, I would just like to look at what is called system of linear equations and solve an example and then end the class there itself. All right. So let me try to do that. So what is the system of linear equations? So consider the system. So system of linear equation. So my system that I'm going to look at, we generally write it as Ax is equal to B, where A is going to look like A11, A12, A1n, AM1, AM2, AMN. X is going to look like unknowns X1, X2, Xn, and B vector is going to look like B1, B2. That's the way it is going to look like. Is that okay? And this corresponds to looking at, if I want to look at from the point of view of equation, not in form of matrix, then it comes to look like A11 X1 plus A12 X2 plus A1n Xn is equal to B1, A21 X1 plus A22 X2 plus A2n Xn is equal to B2, and so on till AM1 X1 plus AM2 X2 plus AMN Xn is equal to Bn. So this is the system of equation, system of M linear equations in n unknowns. So what I would like you to understand here is that X1 is appearing in the first column. So this part is X1. X1 is coming from here. Similarly, X2 appears here. So X2 corresponds to the second column and Xn corresponds to the nth column. Fine. And the right hand side is separately put. Is that okay? So there's a notion of what is called, so this matrix that I'm looking at, this matrix A is called a coefficient matrix. This A is called coefficient matrix. Fine. Writing the matrix A and B together, so if I write it like this, A here, B here, fine, then this is called the augmented matrix. So you have coefficient matrix and you have the augmented matrix. So augmented matrix means I'm putting the right hand side also. So the right hand side B comes here. There is no B coming into the coefficient matrix. All right, fine. So let's just solve an example and then end the class. Fine. So what we would like to do is look at the following system of equation. X plus Y plus Z is equal to 4. 2x plus 3z is equal to 5 and y plus z is equal to 3. Is that okay? So this corresponds to the augmented matrix that I would like you to understand here. 1, 2, 0. Again, look at y. Y is 1, 0, 1. I'll do mistake maybe 1, 3, 1. And you have 4, 5, 3. So this is the augmented matrix that I am looking at. Fine. So this is my AB. That's what I'm saying, augmented matrix. B is the right hand side and A comes from the coefficients of the variables x, y, and z. Fine. The first column corresponds to the variable x, second to y, third to z. All right. You can change your orders and so on. So if I want to solve it, what generally we do that we will use the first equation and make the second entry 0. All right. So what we are going to do is we are going to do, all right, R2, the second row or second equation needs to be replaced by second equation minus 2 times the first equation. All right. So second equation minus 2 times first equation. This is what we are looking at. All right. So if I do that, what do I get here is, you can just look at this, unless my calculation is wrong there. So x plus y plus z is equal to 4. The first equation remains as it is. Second equation becomes minus 2y plus z is minus 3 and y plus z is 3. Similarly, if you look at the rows here, again the same thing will happen, that the corresponding entries will remain the same. So 1, 1, 1, 4 will come. X is 0 here, so you'll have 0 here, minus 2 here, 1 here, minus 3, 0, 1, 1, 3. This is what you'll get. So I would like you to see that second row. So just look at here, R2. R2 is 2, 0, 3 and 5 here. This minus 2 times 1, 1, 1, 4. It gives you 2 minus 2 is 0. 0 minus 2 is minus 2 here. 3 minus 2 is 1. And 5 minus 8 is minus 3. So this is what you are getting here. This is what I would like you to see here. Fine. Just try that out and understand it. Similarly, now I can use this equation again and then remove it. I can interchange the rows that I am allowed, or I can just do it. So I can look at here as x plus y plus z is 4, minus 2y plus z is minus 3. Now multiply this by half and add, you'll get 0 here. So you're adding here, so you'll get 3 by 2 z is equal to 3 by 2. And this corresponds to looking at 1, 1, 1, 4, 0, minus 2, 1, minus 3, 0, 0, 3 upon 2, and 3 upon 2. So how did I get 3 upon 2? That's important, that you need to understand. Fine. So 3 upon 2 is basically the third row minus or plus half times the second row. I'm looking at third row plus half times. So what is the third row? Third row is 0, 1, 1, 3 plus half times the second row 0, minus 2, 1, minus 3. So if I do this, you can see that it is 0, 1, 1, 3 plus 0, minus 1, half minus 3 upon 2. So if you do this, you can see that you will get here 0, 0, 1 minus 1 is 0, 1 plus half is 3 by 2, 3 minus 3 by 2 is 3 by 2. All right. So you get back this. And from there, you can get your answers as, from here, you can see that you can get your answers from here as 3 by 2z is equal to 3 by 2, implies z is 1. Similarly, the first one will give you, so minus 2y plus z is minus 3, implies minus 2y is equal to minus 3 minus z, which is minus 4, implies y is 2. And similarly verify that x is 1. All right. So you can solve the system and you can get it. So the given the solution set is given by x is 1, y is 2, and z is 1. Is that okay? So that's all in this class. Thank you.